Let's talk about common mistakes with synthetic division. A lot of times when students are working through synthetic division, they let their guard down about making some mistakes because they perceive synthetic division to be easier than long division and factoring. And while that can be true in many circumstances, I don't want you to let your guard down. In this video, I'm going to go over the 5 top mistakes that I see students make on their tests, their quizzes, and their exams that make them get the problem wrong, all through working through synthetic division. And I'm not happy to admit it, but some of these, actually all of these mistakes I have made on my own, working through problems and actually even teaching inside of a class. So let's kind of go through all of these. So therefore you can get a better understanding of what these mistakes are so you do not make them. All right, so the first one is not using your zeros, okay? It's very important when you have a synthetic division problem that you are setting up, and let's just kind of give you a generic problem. I'm not going to actually work through the synthetic division algorithm. I'll have some videos to link in the description down below that you can check those out if that's what you're looking for. But it's very important when we go and set up the synthetic division algorithm, we're going to create this nice little synthetic division box, and we're going to take the coefficients of our dividend here, and then we're going to take our divisor and we're going to put it on the outside. Now, the mistake that students will make, and sometimes it's just an unconscious mistake, they see a -1 and they put that right there. But ladies and gentlemen, that is incorrect. X minus 1 is the factor, right? We're trying to determine, does x minus 1 divide into x to the 4th minus 3x cubed plus 2x minus 1? And is it going to divide in there evenly with the remainder 0, or is there going to be a remainder? When we're doing synthetic division though, unlike long division, we're not actually going to use the factor. What we're going to do is use the 0. So what we have to do is take our divisor and set it equal to 0. So now when I have x minus 1 equals 0, I'm going to add a 1, and then x is equal to 1. And so the reason why I say that's a 0, because if x minus 1 evenly divided into this polynomial, then x equals 1 would be a 0 of that polynomial, okay? So it's just very important to make sure you always take your factor or your divisor and set it equal to 0, okay? Don't just take the number that you see up there in the front, all right? Now let's go and look at number 2, which is going to come into when we have to divide out an answer. So sometimes we have something like this. So if I have like a 3x cubed plus, again, I'm just going to make up some numbers, 5x minus 1. And then let's go ahead and divide that by a 3x minus 2, right? Now, again, we're not going to take the -2 here, right? We're going to do the exact same process, not make the same mistake. We're going to set our factor equal to 0, and we're going to get x equals a positive 2/3. Now, when we go ahead and set up our synthetic division, we're still going to take our 2/3, put it over here. We're going to take the coefficients, put it over here. And then again, I'm just making up this answer. I'm not going to work through it. But the main thing that we always do is we're going to have this first one's going to be a freebie. All right. Now I'm just going to make up some numbers here just so we can get this like 6, 12, and a 3, right? Whatever may be the case. Okay. The important thing that we need to make sure we do is whenever we have a coefficient of our linear term here, we need to make sure we divide our quotient here by those values of 3. And I'll explain why this makes sense, okay? Because let's just say, actually, let's say this goes in there evenly with a remainder of 0, okay? So let's put that, let me actually erase that. So we'll say that, hey, let's say this evenly divides into their 0 times, okay? And again, I'm just making up some random numbers, pretending I went through synthetic division. So what that means is if 3x minus 2 evenly divides into this polynomial, it's going to go into that polynomial this many times. Now, again, we need to write this in as a factor. So we have a 3x minus 2. And what would that multiply by to get us this original polynomial? Well, if we don't divide by 3, that would be this. This would be your constant, your linear, and your quadratic. So that'd be a 3x squared plus 6x plus 12. Okay, that's how you'd write that quotient right there. But ladies and gentlemen, that's incorrect, right? If you don't divide by 3, that's not going to give you an original polynomial because again, just do some inspection of distributive property. When I multiply a 3x times a 3x squared, that's going to give me a 9x cubed. I need to get it to be a 3x cubed. So what would be the correct way to do this? What you need to do is when you divide all those terms, and again, remember these numbers are all incorrect, but you would divide everything by 3. So that would give me a x squared. That would give me a 2x. That would give me a positive 4. And again, these are all wrong, so don't worry about them. But what I want you to see here is look what happens. When I do a 3x times a x squared, that gives me a 3x squared. So you have to make sure you account for that. It's one of the more common mistakes, and I've done it multiple times because I'm teaching, I'm thinking about something else, and I forgot to do this extra step, okay? So it's very important to set your factor equal to 0, but when you recognize you have that coefficient, make sure you divide your quotient from your synthetic division by that coefficient as well, all right? Number 3, it's a pretty obvious one that happens a lot. And again, sometimes I don't teach it for long division, but then when we get to synthetic division, it's a necessary thing to do. So if I have x to the 4th minus 1 divided by x minus 1, okay, we know we have to have a 1 here on this outside. And now we're going to take the coefficients. But again, what will students do? They will forget that for synthetic division, we have to make sure we include all of the space values. So what we need to do is we need to write this out in expanded form. There's no x cubed, so we can write that as a 0x cubed. Because again, what is 0 times x cubed? It's just 0. And then plus a 0x squared, plus a 0x, and then minus 1. So to do synthetic division properly, we need to make sure we include each and every one of these coefficients. So it's 1, 0, 0, 0, negative 1. Now you can work through the synthetic division process, okay? So just remember when you're setting up your synthetic division, make sure, when you're setting up your synthetic division process, make sure that you always have things in descending order, and then always check to make sure you have that highest power, and then each and every power after that, so therefore you can figure it out. Now, the next one comes into, again, something that a lot of students get and understand, but when it comes into taking a test or it comes into taking a quiz, they kind of forget about it. So let's just pretend we have something going on like this. And I don't know, I'm just going to pick out some numbers here, 4, 5, 6, 7. Let's just do this, okay? And here's going to be our answer, right? And let's say 4, I'm just going to pick out some numbers here. Okay, let's just see, we're doing a random problem. And then let's do this as -8, 0. Okay. So most students remember that our final answer is going to be our remainder. If we get a 0, then we know whatever divisor that we are trying to divide into our polynomial evenly divides into it. And it evenly divides into it this many times. But again, unlike long division, we have to decode what exactly it's giving us. So the way that I teach this with my students, because I've seen students make mistakes, and a lot of times actually students will make mistakes here, is when one of these answers is actually 0. And I don't know what it is about the 0 that actually makes it confusing for students, but they just don't understand like where things are going to be. Why did I give me the blue? Why things are the way that they are, like, let's say we have a 0 there, okay? So here is the way that I want you to label them so you don't make mistakes. So sometimes students will be like, I don't know, x squared plus 6x plus 4, and they just kind of disregard the 0. So when you are doing this last number is going to be your remainder, always. This last number is going to be your constant. If your constant is 0, then you have a 0, then you don't have a constant. This is going to be the coefficient of your linear, quadratic, coefficient of your cubic. And if you have more terms, you just keep on going higher and higher powers. Okay. So all these numbers again represent from synthetic division is just going to be the coefficient. So this would be a 4x cubed plus a 6x squared plus 4. That would be your quotient. And again, I'm just making up these numbers and problems. But again, a lot of students will do synthetic division right. They do all the work, they do all the arithmetic, but then they label the answer incorrect. They either get confused on what goes what, or they just make a simple mistake from there. So just be very careful when you are having with synthetic division to label everything properly. And the last mistake that I see students make, what was I looking at? Yeah, the last mistake, that's what, the last mistake that I see students make is when they have to do synthetic division twice. Now, there's a couple ways that we can do this. So sometimes I might say, sometimes you might be given a problem, let's say like x cubed plus 2x squared plus 5x minus 7. I'm just going to make up some random numbers, okay? And we're going to say that it has like zeros of -1 and 3. And then it's like, find the remaining zeros, okay? That would be one example. Or again, these are completely made up, but I'm just using these to teach. Or there might be another example where it's like, hey, you have, x minus I, as a 0, find the other remaining zeros. Okay, so here's what happens. We have 2 zeros, or it could be 2 factors, whatever may be the case. We could say, hey, here's a factor, right? So you're given 1 factor, find the remaining factors. Or if you're given like 2 zeros, doesn't matter. It also could be irrational. But here's the mistake most students will make. So let's teach it with this first one, and then I'll show you what you guys do. So most students are like, hey, I'm given the 0, right? So that's cool. So let's go ahead and set it up. So we get a 1, a 2, a 5, a -7. And let's say we get our answer. And again, I'm just going to make up complete numbers. So just follow me here. And let's just say this is a, 1, -3, a 2. And obviously it has to be a 0. So that's going to be a positive 7, 0. Okay. So then what students will do is they'll go back with their next 0, but then they'll redivide it by the same coefficients. And ladies and gentlemen, that is incorrect. Okay, when you are doing, that's like taking 12, dividing it by 4 to get 3, and then taking 12 and dividing by 3 to get 4. That's not going to give you all the factors of 12, right? You're just dividing by different numbers in that case. So what we need to do is further break it down. It's like taking 12, dividing it by 2 to get 6, and then dividing 6 by 3, right? You're continuously breaking things down, or continue breaking it down. So what we would need to do in this case is not take the coefficients from the original problem once we already did, but what you'll want to do is take the coefficients from your previous quotient. So 1, 3, and 2. Then you can go ahead and break that down. Okay, so that's what you'd want to do in that circumstance. And the same thing happens, if we have like an I. Students, you set up I correctly. So it's a 1, a 2, a 5, a -7. And then when you do the conjugate, do not do it with 1, 2, 5, and -7. You have to do it with the next results that you're going to get. And a lot of times, guys, it's going to get confusing. It's going to be like a 1 minus I, and then you'll have like a 2 and a 0. But you're like, how am I going to add this? It's okay. Follow the process. Like 1 minus I, 2, and then go through synthetic division from on there. Okay. So that is the more common mistakes I'll see from students making them. Hopefully this video was helpful for you. If you want to know some tips to avoid making these mistakes, or if you just want some examples of me working through synthetic division, the difference between synthetic division and long division, then check out the links I have for you down in the description down below, or the next video I have for you here. Cheers.